Valeri is
I'll just stick with this guy.
He's a node engineer at Mongo. He coined the term mean stack in a blog post for Mongo. So I think that's like we say in computer science, the hardest thing is naming things. So someone naming the mean stack, I think it's awesome. He's a maintainer at Mongoose. So if you have Mongoose issues, talk to him afterwards.
Open up my GitHub issue. I feel like I'm gonna get inundated.
You guys use Level Up. He's also one of the original founders of Level Up. That's app you see in all the stores. And he's psyched to be here as well. So let me kick off your slides, Valeri.
Sweet. Thanks, David. Let me give me a second. Slides.
And do you want this?
Oh, yeah, if you could get me the clicker, that would be awesome. Thanks. Can everybody hear me okay? Everything work? Awesome. In which case, let me see, is this, all right. Cool, so the clicker works. Great. So thanks, everyone. Thanks, David. It's really an honor to be here. I'm really happy that like schools like this actually exist, so I'm really stoked. So my name is Valeri Karpov. I'm a node engineer at MongoDB. And I'm going to be talking to you guys a little bit about like how I got involved in JavaScript, why I think JavaScript is important, and sort of how I think that people can be better JavaScript engineers. So a little bit more about me. MongoDB Node.js engineer. I maintain Mongoose and a bunch of other related NPM modules. I'm the author of a book called Professional AngularJS. Check it out on Amazon. It's a great way to learn Angular or learn some advanced topics about Angular that you might want to learn about, like SEO or something like that. I blog for StrongLoop. I co-founded Level Up back in college. Back then, it was a text message-based scavenger hunt company, which back in the days before the iPhone. I think it might have been like the first multi-million-dollar mobile gaming company, but I have no idea. So formerly Level Up, I started a company called Ascot Project, which is where mean stack came out of. And the DNS for that company is actually expiring today, so grab the domain name if you really want it. And yeah. Fullstack exclusive, and I'm currently an advisor and formerly CTO of a company called Bookalocal, who is actually hiring. So if you're looking for a job, check them out. And also, finally, coined the term mean stack in a blog post back in April 2013, give or take. So let's get started and sort of talk about how I got into JavaScript. I came to JavaScript from a very odd background. In undergrad, I majored in theoretical computer science, which is about as far as you could possibly get from JavaScript. My senior independent work, I proved a linear algebra lemma or something like that. There was a lot of divergence operators and crazy things, and not very much code. So I very much came from a place that wasn't JavaScript-like. But I decided that I didn't want to be an unemployed PhD student for too long. So I just wanted to get into industry. And when I got into industry, I started working in high frequency trading. And on the side was working on a couple of like small startup projects with buddies from college. And this basically led to me doing an awful lot of context switching between Python, C++, iOS, Android, Java, a lot of different things, and all of them had one thing in common, which I don't like, which is threads. And you'll see me hate on threads a lot in this presentation, because I don't really think that multi-threading is it's useful, but in a very limited use case. So threads and locks were basically the bane of my existence, because all these languages have one thing in common, and that's that the only way to do concurrency in any of them is with threads and locks. So one of the primary projects that I worked on during this time was originally called Tabby, pivoted to a company called Nightlife, which then became Ascot Project via a few different pivots and migration between a bunch of different team members. But for most of the time of this company's existence, we were working sort of Python, Ruby on Rails, iOS, Android, building mobile apps, that sort of thing. And we had a team of 4 pretty smart engineers who now have gone on to do pretty impressive things. Guy was director of product at 11 James, who actually just recently hired a couple of Fullstack grads. And a couple of guys who, including the co-founder, VP of product for a company called Booster Fuels based out of Seattle, which is basically the leading Uber for gas company, I think is their kind of the short way of describing what they do. So and between the four of us, we managed to somehow maintain 4 code bases in 4 different languages. And smart guys, all of us. And we, much to my shame, we once spent 3 days debugging a stupid race condition in our Android app that prevented images from loading in the right order and made it so that all of our images were loaded in the wrong way. That was pretty embarrassing, and that was actually killed my summer vacation in 2012. So I vowed never to get stuck in that again. So lessons learned from that. Actually, part of the reason why I got into Node was a conversation that I had about 2 blocks away from here with this guy, where we were talking about, oh, hey, how could, so if we were to like start off over from scratch on the Tonight Life API, what would we do it in? And he was like, oh, we should probably do it in Node because Ruby on Rails, bloated as can be, really just, whenever things, Ruby on Rails is great when you do things in the Rails way, but as soon as things go off the rails, pun intended, they go really off the rails, and you just spend all of your time trying to figure out what did I do wrong? Oh my God, everything just blew up. So that's what we didn't want to do anymore, and that's why we switched over to Node. And also, threads are very hard. I'll leave that to the PhDs and the experts on the V8 team to figure out, because I don't want to deal with that. Sharing code also became sort of like very much part of our mantra because, well, when we had 4 separate code bases in 4 different languages that all implemented pretty much the same functionality in a lot of different ways, so we wanted to make sure that we could sort of harness all of the work that we did in various parts of our application, and also trying not to do too much real engineering, and I'll talk a little bit more about that in the slide after the next one. But first, code sharing. So maybe a controversial statement, but before ES6, JavaScript was an awful language, and it's still not, I mean, I'll be first to admit, like probably C# and F# and all these other crazy languages are probably better in general. But the best part about JavaScript is that it used to be a really awful language and is now less awful. So back when it was really awful, people learned how to share code. And the sort of, I will forgive any level of sin in a programming language as long as it's really easy for me to share code so I can solve all of the pain points and then just reuse that solution over and over and over again. So, and you can tell that this is sort of something that's a big deal in JavaScript by the sheer number of package managers that are floating around. I mean, everybody's heard of NPM, Bower. There's new ones popping up every day. A couple of weeks ago, I ran into Duo for the first time, which is a front-end package manager developed by the guys at Segment, sort of based loosely on some of TJ Holloway-Chook's work on components and built by Matt Mueller. There's also TSD, which is sort of like the NPM for TypeScript, and a bunch of other crazy NPM modules. Even TJ actually ended up writing not 1 but 2 NPM replacements, which is pretty crazy. So yeah, learning how to share is important. And also the point about being a real engineer is, so one of my former colleagues at a past company once said this really great quote, and he meant it in sort of like a derisive way. It's just like, oh, JavaScript isn't real engineering. But then I'm like, yes, that's exactly what I want like my day-to-day coding life to be like. I want to feel like I'm playing with Legos and assembling this really cool thing out of like, you know, out of blocks that I have already built, out of APIs that are available over the network, plug them together and build something great, so I don't really have to worry too much about doing real engineering. Also, another great quote related to this by actually a guy who was one of my mentors when I was in college, Brian Kernahan, kind of a famous software engineer, a guy who wrote the book on C, among other things. So debugging is really hard. It's harder than writing the program in the first place, so don't be too clever. Otherwise, you'll never be able to debug it. You'll never be able to improve its performance. You won't be able to support it. Basically, you have to be a lot smarter than the code that you wrote in order to effectively maintain it. So general idea, keep it simple. Build sweet things out of Legos. That's the most important thing you should get out of this slide. So plug and play existing blocks. There is an API available on the network for just about everything. A recent company that I ran into was, have you guys heard of Vero before? V-E-R-O? It's a really cool company with a really interesting business model. Their whole idea is they basically replace your transactional email. So they do analytics tracking, but also you have the ability in Vero's console to say, okay, every time I get this event, send out this email after a certain period of time. So you don't have to write transactional email anymore. All you have to do is track events, which is totally awesome. So, and what JavaScript is uniquely positioned to do there is event loop makes network I/O super easy. You don't have to spawn off a separate thread to do an HTTP request. You just kind of include, you just kind of do, okay, here's super agent, let me do an HTTP request. Or one of my former colleagues put up a Vero wrapper on NPM. So now all you have to do is just require Vero and just call a couple of functions, everything works. Beauty of JavaScript. So after Tonight Life and that whole deal, we pivoted to become a company called Ascot Project, which was sort of a fashion thing for tagging, what do you call it? Basically like tagging articles of clothing and images and sort of displaying that in a dynamic overlay that could scale across multiple verticals. We basically built this at a hackathon in 2012, so we literally went from having nothing to having revenue in 24 hours, which was really cool. Not much revenue, unfortunately, otherwise the company might still be around, but again, because of the event loop, it was super scalable, super easy to build. Built it up really quickly, and most importantly, the whole team, all of those guys who were previously working on separate components of the application and having to sort of communicate iOS or Objective-C paradigms to somebody who was spending their time working in Java, we could just basically have everybody join forces and work on roughly one code base and be able to switch back and forth between different pieces with ease. So where I think JavaScript is going in the future, again, I really think that the event loop is JavaScript's #1 killer feature, and I think that sort of going forward, if JavaScript isn't really the language that most developers write in 10, 15 years, it's going to be something else that's going to be based on an event loop. Because again, there's an API in the network for just about everything. And I think most engineers in that case will be more like sort of Scott Melker, my favorite mashup artist, than Mozart, sort of just composing new work from the ground up. So yeah, other killer features. Code sharing is very important, but also adoption. That's one of the things I think that makes JavaScript super important is just about everybody has or is writing some sort of JavaScript. And that's kind of why JavaScript has sort of grown so much, is that Node kind of makes sense because because everybody has written a little bit of JavaScript in the browser at some point. You know, everybody has sort of finagled together a website for fun, plugged in some JavaScript, makes it a lot more accessible than a language like, say, F#, which I still have never written even Hello World in. But yeah, so JavaScript is, of course, not just for the browser. There's a lot of really interesting applications of JavaScript that sort of apply some of these really core language features in really interesting ways. Obviously, server-side, you got Node.js. You also got Mozilla's Rhino, which is sort of a Node.js predecessor. You can build mobile apps with things like the Ionic framework and React Native. And there's also other crazy scripting environments like the MongoDB shell, which I'm sort of working on a proof of concept for replacing. There's the Nginx scripting language, and there you can even sort of write Photoshop plugins in JavaScript, which is really cool. So server-side JS, why I think that's important. Event loop for performance, code sharing. Don't block the CPU or don't block the CPU with I/O. That's the whole point of the event loop. You have a long-running operation to the database. You don't want the CPU to be occupied and not processing other requests. Otherwise, you get backed up and everything blows up. Mobile apps, again, one thing that we learned the hard way at Tabby/Tonight Life is that maintaining and writing an iOS application is probably a full-time job for at least one person. At the very least, if you get yourself a real rockstar mobile dev, they can probably do Android, iOS, and Windows. But that's already one person who probably could be more useful if you hired somebody who just knew JS and then could sort of work a little bit on your mobile app, work a little bit on your server, work a little bit on the desktop client, instead of just having like a dedicated person who just is very heavily siloed. Oh, and another good point is that, again, a lot of mobile apps nowadays, why I think Ionic framework is so important going forward is, well, what we struggled with a lot at Tabby and Tonight Life was that it's actually surprisingly tricky to get things like asynchronous image loading down when you have to worry about multi-threading and trying to figure out all of these race conditions that ruined my summer vacation in 2012. Whereas a browser is very, very good already at making HTTP requests, loading images, doing all of this stuff. So like, why reinvent the wheel and why implement it yourself when you could just have Cordova do it for you? And so another interesting feature of JavaScript, and sort of why JavaScript is a great language for things like the MongoDB shell and Nginx's new scripting language, is that core JavaScript actually makes no assumptions about I/O or the existence of anything else in the universe. Everything that's defined in the ECMAScript 6 is all in memory operations. There's nothing about files or XML HTTP requests or any of this stuff. All that stuff is either is injected via the browser or via whatever runtime environment is responsible for giving JavaScript a view of the world. So in that case, if you want a scripting environment that doesn't give somebody access to the file system, JavaScript is absolutely perfect. So a couple of little tips for being a better JavaScript engineer. I don't know, or at least some things that I think would be helpful, or little tips I think would be helpful. So what I think that JavaScript is really all about is sort of getting out of your way and letting you work on things that really move the needle on the business. Because every time you're debugging a race condition, or times when you're trying to figure out how to get this little bit of concurrency quite right, it's time that you're not spending developing a new feature, integrating better analytics, iterating on feedback. It's just wasted time. When you're focused, when you've got these code sharing and when you've got the event loop, you're primarily focused on sort of, how can I implement this new feature? How can I just sort of, how can I get this data out here? How can I plug this data in here? And that's sort of stuff that really actually matters. Now, what it's not about is slow compilation times. And so, funny story why I have the James Bond thing up there. When I was in high frequency trading, we had this one really slow compiling piece of code that even if you made sort of one change in this one piece, you would have to wait about 10 minutes for GCC to compile the damn thing. And so whenever I would make a change and start waiting for it to compile, what I decided I would start doing is just start reading a little bit of a James Bond novel. And well, pretty soon, by the time I left the job, I had read every single James Bond novel from Casino Royale all the way up to Man with the Golden Gun, or at least every single one that had been written by Ian Fleming. So yeah, what JavaScript I think is really about is things like gulp, grunt, etc., karma, all of these test runners, MOCA, is all about sort of getting you faster feedback on your work and sort of reducing the time that it takes to go from hypothesis, have I fixed this, to yes, I have fixed it, or no, I haven't fixed it, I need to go try something else. And less time spent, riding around on chairs playing with swords and reading James Bond novels. So another thing that I really kind of value is, again, going back to the Kernahan quote, is try to be not clever. Whenever you try to just be really clever with a solution to a programming problem, you forget the fact that you're going to have to explain that code again. And generally speaking, for every time you write a line of code, somebody is going to be reading that code 10, 20, 100 times. So before it gets changed again. So you might as well just write code that's easy to read, easy to grok, as opposed to trying to come up with the most clever solution you possibly can. And that's not even taking into account the fact that you have to debug the code, support it, et cetera, et cetera. Another thing that I really wish somebody had told me when I started my engineering career is I for some reason was under the false assumption that if you're once the project is done, then I could just go and retire on my private island and do nothing. That's very much not the case, because even when the project is feature complete and everything is good to go, there's still a lot of stuff that you need to do. Users always come up with weird ways to break your code. Or the problem ends up being on the other side of the keyboard and you got to prove it to them. Stuff like somebody insisted once that our login system was broken, and I'm like, no, it's not broken. And then I look in the logs, and it turns out they were logging in with a username, as opposed to, we specifically asked them to log in with their email. we didn't even have a username in our system. They were trying to log in with a username that they had for a different website. So yeah, problem on the other side of the keyboard. Debugging, performance, and later on even documentation and teaching somebody else about your code. All of these are jobs that you just got to keep on working on, and sort of writing new code is not even close to the entire job. And another important thing is like always keep working on yourself. My favorite, as you might have guessed from my Twitter handle, Conan the Barbarian 1982 is absolutely my favorite movie of all time. It's the greatest thing ever. And so one particularly poignant quote that I really like by the film's main villain, played by James Earl Jones, is he explains to Conan that a tool is really only as good as the person that's using it. So like you should be working on expanding your mind. You should be taking care of yourself, getting enough sleep, learning new things, working on your communication skills. Because again, if you don't have that, even the best library in the world won't help you out that much. And last thing related to working on yourself, documentation and especially communication. That's something that's going to be a lot more important in code going forward, especially since we're moving towards a place where, network API for everything, code sharing all over the place, open source modules, plugging all this stuff, plugging in all these Legos together to build a new system. You need to be able to communicate how these little blocks work together and how they fit. And used to be in the olden days when you just had a big monolith, you just give somebody access to the code base and expect them to figure it out themselves. Nowadays, that's becoming less and less feasible. So we're going to have to focus a lot more on sort of communicating and, well, helping people learn how to code and how to work within new paradigms, which is what Fullstack is good for. So that's about all I have, I think. Oh man, the clicker broke. Oh yeah, it's not. Well, the last slide is, hey, thank you guys very much for listening. I hope you got something useful out of it. That was about 20 minutes, so.